Our lesson 7.5 is about polynomials, and so this video is going to serve as an introduction to those polynomials. Let's get started. In this lesson, we're going to define several new vocabulary terms, and the first one is called monomial. As it says here, a monomial is a number, a variable, or a product of numbers and variables with whole number exponents. Product means multiplied. So what we're really talking about is variables and numbers multiplied together. Okay, so here are some examples of monomials. 7x is a monomial. 25x squared is a monomial. It can have positive whole number exponents. 13x to the fifth, y to the fourth, m to the seventh, that's a monomial. Basically what we mean when we say monomial is one term. Okay, that's what monomial means. It means one term. So all these guys here are terms. Even the number 12 is a monomial. It's a product of numbers and or variables. Right? It says or right here, multiplied together. So all these guys are monomials. Let's give a few examples of things that are not monomials. Negative 0.3 times x to the negative 2. That's not a monomial. Okay? We need positive exponents. So we'll cross that one off. How about 4x minus y? That's also not a monomial because it's two things that are subtracted and ours need to be multiplied together. And what about 2 over x cubed? Also not a monomial. That turns into be 2 to the x to the negative 3, and that makes a fraction. It's not stuff multiplied together, it's divided, has a negative exponent, so we cross that off. These are not monomials. These guys are monomials. So once you figure out that you have a monomial, there's some things that we can determine about those monomials. Let's take a look. Here's another new vocabulary term. The degree of a monomial is the sum of the exponents of the variables. A constant has a degree of 0. So if it's just a number, the degree is automatically 0. But for monomials that have variables, we are going to add up all of the exponents of the variables. Okay? So let's try this. Let's consider negative 2a squared b to the fourth. Well, we have two variables. The a is squared and the b is to the fourth power. So to find the degree, we just add up 2 plus 4 and we get 6. And that's the degree of our polynomial. Our degree is degree 6. What about the number 4? What's the degree of 4? Well, this is a constant, so the degree is 0 because it's a constant. And let's try something else. What about 1.5 k squared m? Well, to get the degree of this, we have to look at the variables. This k has an exponent of a 2, and this m, even though it's not written, has an exponent of 1. And so the degree here is going to be 2 plus 1, which is 3. So the degree here is 3. Any monomial that we can write down, we can figure out the degree. For monomials that have variables, we simply add up the exponents on the variables. For constants, it's easy. The degree is 0. Okay, so what are we going to do with these monomials? Well, that's what the next slide's about. What we can do is we can take a bunch of monomials and we can add them or subtract them to construct what we call a polynomial. So a polynomial means many terms. A polynomial is a monomial or the sum or difference of monomials. Let me give you some quick examples and then we'll talk about the degree. So we're going to work with polynomials that look something like this. Something like x squared plus 4x plus 4. That's a polynomial. Or 0.5 x squared y plus 0.25 xy plus 0.75. That's a polynomial. And what about 6x to the fourth plus 9x squared minus x plus 3? Each of these expressions is a polynomial because it has many terms and they're added or subtracted. Now, once you have polynomials, you can talk about the degree of a polynomial. The degree of a polynomial is not the same as the degree of a monomial. To find the degree of a polynomial, we look for the term, which is a monomial, that has the greatest degree. So you have to look at each term separately, figure out its degree, and then pick the biggest one. Let's take an example. Let's look at an example with these three polynomials we have here. In this first polynomial, x squared plus 4x plus 4, the first term has degree 2 because the sum of the exponents is 2. The second term has degree 1 because the sum of the exponents on the variables is 1. And then this last guy, the degree is 0 because all it is a constant. And the highest of those three numbers happens to be 2, so this polynomial has degree 2. It's a second degree polynomial. In the second polynomial, 0.5x squared y has a degree of 3 because 2 plus 1 is 3. 0.25xy has a degree of 2 because 1 plus 1 is 2. And then 0.75 is a constant. It has degree 0. The highest number here is degree 2. It's 3. I don't know what I'm talking about here. So this polynomial has degree 3. We can do it with this last one. The degree here is 4 because there's only one exponent, and so when you add those up you get a 4. This degree is 2, this degree is 1, and this degree is 0. The highest number is 4, so the degree of this polynomial is 4. We do not add up all of the exponents for the entire polynomial. We look at each term separately. That's why I've written a 2, 1, and 0 above the terms in this polynomial. And I picked the 2 because it was the highest. I wrote 3, 2, and 0 in this polynomial and picked 3 because it was the highest. And in this last polynomial, 4, 2, 1, and 0, I picked 4 because it was the highest. Now the rest of our chapter is going to be dealing with these polynomials, and so it's going to be important for us to have a standard way to write them. In fact, there is a standard form for a polynomial. Let's see what that's all about. When we talk about the standard form for a polynomial, we're going to focus on the polynomials that only have one variable. Usually that variable will be x. And to put it in standard form, we simply list the terms in order from greatest to least in terms of degree. So we start with the highest degree and work our way down to the lowest degree. When you're all done writing it in standard form, the number out in front of the first term, that's called the leading coefficient. So let's take a quick look at some polynomials. Let's go back to that polynomial that we had on the last screen. 6x to the fourth plus 9x squared minus x plus 3. This is a polynomial and it happens to be written in standard form. Look at the degrees. The degree here is 4, the degree here is 2, the degree here is 1, the degree here is 0. That's written in order from greatest to least. We call that descending order. And then the leading coefficient, which I'm going to abbreviate as LC, it's the first number in front of the first term. The leading coefficient for us is 6 in this case. Now, sometimes polynomials aren't written in standard form and we're asked to put them in standard form. So take a look at this one I'll write in blue. 20x minus 4x cubed plus 2 minus x squared. So these terms are all mixed up. The degree here is 1, the degree here is 3, the degree here is 0, and the degree here is 2. What we need to do is put these in the right order. And we need to be careful to keep the minus signs with the coefficients that are after them. So here's what this polynomial looks like in standard form. It would be negative 4x cubed, that's the highest degree term, minus x squared, that's the second highest degree term, plus 20x, and then plus 2. And that leading coefficient turns out to be negative 4. It's the coefficient out in front of the highest term. As we start writing polynomials in standard form and talking about their degree and their leading coefficient, turns out we see that these things fall into categories, and so they've developed a way to classify these polynomials. These two tables here show the two different ways that we can classify a polynomial. We can classify them by their degree and also by the number of terms they have. And so what we're going to do is we're going to refer to these tables quite a bit. In fact, I'm going to have you memorize these things and take some quizzes over it. But what we'll do is we'll look at some polynomials and we'll give them two names. One name will come from the degree list and the other name will come from the number of terms list. Take a look at this one. Here is a polynomial, 5x minus 6. The two names that go along with this are linear, because this thing has degree 1, right? This is degree 1, this is 0, so the whole thing is degree 1. This is a linear, because it's degree 1, and it is a binomial because it has two terms. Right? Binomial is right here in the list, linear is right here in the list. Let's take a look at another one. What about y squared plus y plus 4? Well, the highest degree here is 2, so you can see that word is quadratic. And it has 3 terms, so that word is trinomial. So this is a quadratic trinomial. Its highest degree is 2, the y squared term, and it has 3 terms total, so that's a trinomial. So get familiar with these charts. We're going to be practicing naming these things, and then, like I said, taking a few quizzes. One quiz where we'll just fill in the charts, and then another one where we'll give you some polynomials and ask you to pick out the two names. The last thing we're going to do in our introduction to polynomials is just practice making some calculations with polynomials. So take a look at this firework physics application. A firework's launched from a platform 6 feet above the ground at a speed of 200 feet per second. The firework has a 5-second fuse. The height of the firework is given in feet by the polynomial negative 16t squared plus 200t plus 6. And t is the time in seconds. How high will the firework be when it explodes? Well, the fuse is 5 seconds, so it's going to explode in 5 seconds. And so what's this telling us is that t equals 5 seconds. So what am I going to do? I'm going to plug I'm going to plug 5 in where t is. So the calculation that we'll do, and you can use a calculator on this, is going to be 16 times 5 squared. That's going to be 25. The 5 squared is 25. Plus 200 times 5 plus 6. Okay, well, let's see if I can work this out here. So negative 16 times 25 plus 200 times 5, I know that number, plus 6. This is going to be negative 400 plus 1,000 plus 6. It looks like that turns out to be 606 feet, if I'm not mistaken. Yep, that turns out to be 606 feet. And so we know that when that thing explodes, it'll be 606 feet in the air. And that's just a little application working with polynomials. All we did is plug the numbers in, so don't panic here. You put the numbers in, you follow the order of operations, you crank it out on your calculator, and you can solve these problems. Okay, well, that was an introduction to polynomials. Good luck, and we'll talk more later. Have a good one.